polymorphism is basically when the object is defined to do something, but it can do or perform some actions on data, which the data is not really defined from the beginning. So you might polymorphism basically mean multiple shapes. So there are usually you can create objects which can deal with multiple types of data, but do the same action on them. Yeah, and basically protect variation is basically kind of variation of polymorphism. So you want to protect this because there are some, as I told you, some objects can perform operation on multiple types. You want to also protect the variables, so you want to make sure that the instability, so the things that change, can deal with interface and can create the variation. Okay, so this is basically, so those area was the 3 different general databases of principles for object-oriented programming. Then we can look at the object-oriented metrics. So there are a few ways to basically evaluate how your code measures in way of, you know, achieving some good performance. So you basically can define something like a coupling factor. So number of non-inheritance couplings over number of couplings. So you basically can see how many couplings are and how many maximum number of couplings that are possible, and basically find the ratio how many things are connected with how many things, and out of maximum number of possible combination. Basically, then you can also find the lack of cohesion matrix. So basically you can look at the class and basically look at the data fields that the class consists, and basically look at the methods that it has, and basically find the method and how many different data fields it accesses, and basically by this you can find how what's the cohesion metric of this object, basically by finding how coupled is the data and the methods inside the object. And basically you can also basically calculate kind of percentage, and the lower the percentage, the greater cohesion. So when there are a lot of methods access most of the data fields, you basically have a high cohesion because they all operate on the same data. Yeah, link encapsulation. So basically, as you probably know, in classes you can have non-private variables and private methods. So basically, you've got attribute hiding factor and method hiding factor. So how many private variables and method there is in class regarding to all number of all methods. So you can basically then find that what's the percentage of accessible methods and variables. Inheritance. Yeah, so you can also look at the type of inheritance tree, so how many superclasses there are, and number of children, how many subclasses there is in superclass. Yeah, you can also look at the complexity of class, so methods over classes, so how many methods on average there is in the class, number of classes, lines of code. And there are multiple sites available to show you how you can basically find those metrics. And basically you've got those summarized here. So you've got coupling factor, you want to have the lowest coupling, so interference between the classes, like cohesion of methods, so you want to basically have the lowest cohesion. So complexity, attribute hiding factor, method hiding factor, so you want to hide inside the class as much as you want. depth of inheritance. So you want to basically has as little inheritance as you can have, as lowest number of children, as lowest number of methods in some class, and probably high number of classes and low number of lines of code. So you've got kind of static code analysis tool, so you basically can upload your code or download this analysis tool, and basically it will find you some OO metrics. Okay. Now we will talk about refactoring. So it's basically re-implementation of your code to perform the same behavior, but improves the code appearance and technical data. So basically, why would you want to rewrite your code? It's basically just to improve the maintainability and extendability. You want to also limit the technical debt. So technical debt is basically when you write something quickly just to satisfy some needs, some implement, basically do a hack just to make it work. And basically in the future, when you want to maintain it, improve it, you then need to go back to it and see how you've done it and probably rewrite. So you can create this kind of technical debt. So basically writing code very fast just to satisfy some, some behaviors you want to do. But then if you want to in future improve it or add something to it, you will need to pay this debt to clear up the code to make it better. So you want to also align with recognizable design patterns. So there are design patterns, as I told you earlier, and you basically sometimes create the code, it works, but you want to make it more visible and clear and align with design patterns. And basically you want to support that. We can go through some of the reasons to refactor, so to improve your code from already working to working in the same way, but basically make it clearer and better. And this is some of the issues that usually people have when they create the code. So code is duplicated in multiple times, the routines are quite long, the loops are long and deeply nested, the classes has poor cohesion, so it's basically spread on the many different types. Class interference does provide. Yeah, so it's basically so basically it doesn't abstract very well from the data that you have. The parameter list has 10 parameters, so it's basically just to define. Changes within the class tend to be compartmentalized, so when you want to change, you need to change a few things at once in one compartment. Sometimes you can create the code when you want to change, you need to do a parallel modification in multiple classes, so you want to need to change multiple things at once, and it's not welcome. Inherent hierarchies has to. So you can also have a code which, when you want to modify it, you need to modify it different levels of inheritance. Related data items are used together and not recognized into classes, so you have data dealing with the same thing, but they are completely spread in different parts. It's better to make it more together. You can use more features of another. So you basically you can create a class which basically uses all the methods of another class. Then primitive data type is overloaded, so you have one data type and it has multiple underlying types, and it basically is too much. You can create a class which doesn't do very much, just pass the data. You can create the changes of routines which just travels the just pushes the data forward. You can create the classes which does nothing, just does data one back and forth. You can have one class over intimate with another, like sharing too much coupling between. You can have a pool names. The data members can be public where they don't have to be. The subclass only use a small percentage of parents' routines, so you can have a subclass which doesn't need to be really in this place. So also the good written code should be self-explanatory. When you need to write, for each line you need to write a chain of comments just to explain what it does. It's not very clear. Yeah, you sometimes can create kind of classes which, before you call some routine, you need to set up some code, some data before, call the routine, and then clear up afterwards. It's better to have routines which you can call anytime without a specific order. Yeah, there might be some, different couplings problems between different parts of the code. And there's also, as worth noticing, Pragmatic Programming is a book by Andrew Hunt about how to take a pragmatic approach to programming, so how to try to, and it also has some certain rules how to program. Yeah, and I think I will stop here. Yeah, because then. Okay, so just a few notices. So it's not very important for you to know all those stuff. It's nice to follow them if you want to. And I assume in this module you won't do very much object-oriented programming. You probably will use a ROS, but you can create the nodes and services, but you won't really do that many classes. But it's nice to know if you in future will create any bigger projects and this kind of stuff, how to maintain them and align, and how to contain the code into the most efficient way. I'm not an expert in this, as you can see probably. So if you want some much more information about this, probably it's good to research on your own how to look at those things. But probably if you want to be fluent in this, you probably need to do some kind of more computer software module on that. This is just to give you a very quick overlook how it looks like and what you will need. And what else? And basically from this slide onwards, it goes into the interrupts and using of the Git repository, and I would probably move that to the Friday so we can look how to create a Git repository. And then looking in the interrupts and pulling is more kind of hardware stuff for Arduino programming, and this is also basic stuff, but it's more kind of tutorial stuff, so I will move it to Friday. Okay, any questions? It was probably not very exciting. Just a quick question, how many of you got the buggy? Most of you? Okay. Did all of you manage to make the engine smooth and some kind of simple functions to implement some movement? Okay. Did you start working on some sensors or some other output? You've got, as far as I know, LCD and servos and other stuff. Did you start working with those? Yeah. Okay. Because then I assume last Friday and today you're supposed to work kind of on outputs from the Arduino, so kind of displays, servo motors, the motors in itself, and this kind of stuff. And then from Friday we will look at the interrupts and getting the input to the code from kind of sensors. You've got ultrasonic sensor, some other ways, and then basically this will be Friday and Monday, and from Monday I will start going into ROS and programming and about operating system, so we will start using Raspberry Pi. So this is so you're now finishing the first week, and then there will be another week of Arduino, and then we will go into programming of Raspberry Pi. Okay?
We're done.